Hey guys, so today we are going to talk about kind of a review of all the different ways that we can represent quadratic functions. We're going to use a graphic organizer to do that. So if you are not printing your worksheet out, I would like for you to pause the video and set up your paper. You can choose either option. We have option 1 and option 2 here. But you will need a total of 6 of whichever chart you choose. So like this option 1, this is one problem. And option 2, this is one problem. So you're going to need 6 total charts. And I'm going to work out 3 problems. And then you're going to do 3 that are very similar to those. So like if you have, you could label these like your first chart would be number 1, and if your second one was number 2, number 3, this is not the way it'll look on your chart, obviously, because this whole thing would be number 1. But if you numbered them 1 through 6, then you would write the examples I'm giving you in like the 1, 3, and 5 spot, okay? And then the similar examples would be in the 2, 4, and 6. Those would be like the other ones that you fill in after you watch the video. Okay. So at the end of the day, you're going to turn in 6 completed charts that look like one or the other. And it would help you to look at the worksheet as you set this up to make sure that you like that it makes sense and you understand what we're doing. Okay, so this example would go in the first of your 6 charts or rows or boxes or whatever you want to call it. This is the first example. And in this example, we start with standard form. And having standard form allows us to factor. And it also tells us what A, B, and C are so that we can do other calculations, okay? So standard form is what most quadratic equations will be found in. So then we have vertex form. And vertex form, the first thing we're going to do is transform this to vertex form. So in order to write our equation in vertex form, we first have to find our axis of symmetry. And our axis of symmetry is negative b divided by 2a. So in this case, that is going to be negative 8 divided by 2 times 1. So we can go ahead and write down here that a is 1, b is negative 8, and c is 15. So our axis of symmetry is going to end up equaling positive 4. And then we have to find our vertex. So we find the vertex by finding f of our axis of symmetry. So f of 4 is equal to 4 squared minus 8 times 4 plus 15. So this is 16 minus 32 plus 15, which is going to equal negative 1. So our vertex is at 4, negative 1. So then we can write our equation. So remember that vertex form. So on this first one, I'm going to write these, the forms out for you. So this is f of x equals ax squared plus bx plus c. Vertex form is f of x equals a times x minus h squared plus k. And then factored form is f of x equals x plus a. And actually, let's not use a because they're not interchangeable. We'll use m and n because these two numbers are not related to the a's and b's that we use in the other parts. Okay, so in vertex form, this is our axis of symmetry. This is our y-intercept. No. That's our... Okay, I'm sorry, that's not your y-intercept. This is the... K is the y value in your vertex. Your vertex is opposite h, comma, k. Okay, so that means that when we write our vertex form, it's going to be f of x equals a, and the a is from the standard form. And so that's just equal to 1, so we don't actually have to write that out there, times x opposite h. So h is our axis of symmetry, and it's a positive 4, so we do the opposite. So minus 4 squared plus k, and k is what we get when we plug our axis of symmetry into the equation, and so we put a minus 1 here. So we've got, now we have our vertex form. All right, finally, we are going to go to factored form. And factored form is found by using the standard form as well. So we need to factor our equation into two binomials. And in this equation, a is equal to 1, so we don't have to use the x method or anything. But we need two numbers that multiply to get positive 15 and add to get negative 8. So that's going to be negative 5 and negative 3. And the special thing about factored form is that it tells us our roots or solutions or zeros or x-intercepts. You can call it any of those things. We're mostly going to refer to them as roots. So to find those, we set each one equal to 0. And then we solve. So we have x equals 5 and x equals 3 are our roots or solutions or whatever you want to call them. So here is factored form. And now that we have all the different forms, graphing this becomes very simple. Okay, so we know that our axis of symmetry is at positive 4. So I can have a axis of symmetry here that kind of helps me draw my graph. And then my vertex is at 4, negative 1. We learned that from vertex form. So I'm going to put a dot right there. And then I know that my solutions or my roots or x-intercepts are at positive 3 and positive 5. So on the x-axis, I know I'm going to have a point at positive 3 and a point at positive 5. So for the purposes of this exercise, that gives us enough information to draw a rough shape of our graph. And that's all you need for this exercise is just a rough shape. I'm good with that. So everything you see in pink is the information that you need to have on your graphic organizer whenever you do your problems and when you take these notes. So every single box should have all of this information. So we're going to do a couple more examples, but the next examples will start in the different forms instead of starting in standard form. So let's look. This one starts in vertex form. So vertex form tells us an axis of symmetry, which is x equals h, opposite h, sorry. So that means that this is x equals positive 7, because that's negative 7. So then our vertex is opposite h, comma, k. So that's going to be positive 7, comma, 1, because that's our k value. So those are the important things about our vertex. Those are what they tell us. And if you remember from our very initial notes, this -1 as an A value tells us that the parabola opens downward. So this is going to be an upside down parabola. All right, so let's go ahead, and we can't factor vertex form without going to standard form first. So we're going to save ourselves the trouble and start by translating it to standard form. So the first thing that we'll do, I'm just going to rewrite the equation. F of x equals -x minus 7 squared plus 1. Okay, so remember when we square a binomial, that means we multiply it by itself twice. So there's, one binomial, two binomial. We write it down twice and multiply. And when we multiply two binomials, we use the FOIL method. So I've taught you a way to do it with the letters, and you can do it that way. I think it's faster to just distribute each term. So first I'm going to distribute the x, which would be the f in your FOIL method. So we still have the negative on the outside, and everything we FOIL will be in parentheses because we have to apply this negative to all that when we're done. But x times x is x squared. Distribute the x to the -7. That would be your O in FOIL. We get -7x. Then your inside terms, -7x. And then your last terms give you +49. And then we still have our +1 on the end. So I'm going to combine like terms before I distribute the negative because it just saves me some distributing. So I've got x squared minus 14x plus 49 plus 1. Then I'm going to distribute the negative sign, which just lets me flip the signs of everything inside the parentheses. And then finally, we need to combine these last two terms. So -x squared plus 14x minus 48. Now we have standard form. And so once we have standard form, we can identify A, B, and C in case we need to use those for other calculations. So A is -1, B is 14, and C is -48. Now, let's do factored form. We're going to use standard form to give us factored form. So first I'll rewrite it. F of x equals -x squared plus 14x minus 48. Let me draw my little rectangles around the answers so that we can see clearly the three forms. Okay, so we want to factor this equation. So something I haven't really gone over with you guys yet is that when we talk about factoring, we factor like when you can just skip to this step because A equals 1. Well, in this case, A equals -1. It does not equal a +1. So what we can do to fix that is we can factor -1 out as a greatest common factor. And that's going to flip all of our signs, again, kind of undoing what we did in our other calculation. Okay, so now when we factor, we bring down our GCF, and now A does equal 1. And so we can do just two numbers that multiply to get +48 and add to get -14. And that gives us -8 and -6. So the factored form of this equation is f of x equals -1 times x minus 8 times x minus 6. And remember, this tells us our roots. So we can set this equal to 0. And because this has no variables in it, and remember that's the only reason we can do that is because there's no variable, we can divide both sides by -1 and get rid of that. So we get 0 equals x minus 8 times x minus 6. And then set each one equal to 0. And we're going to get x equals 8 and x equals 6. And these are our roots. So now we're able to graph our equation very easily because we have lots and lots of information on it. So first, let's graph our axis of symmetry. That's at x equals +7. So that's this guy right here. And then our vertex is at 7, +1. And our solutions, or roots, are at 6 and 8. So 6 and 8. And if this were pointing up, we would be kind of confused right now, but it's not. It's pointing down, and we learned that from the vertex form, and we can also see that in standard form as well. So we know this parabola points downward, and we can draw the general shape of our graph. Okay. We're going to do one last example where we start in factored form. And when we start in factored form, we know that factored form tells us what our roots are. And we can find those by setting each one equal to 0. And we're going to get that our roots are -7 and -3. And I did those in my head, and you're welcome to as well. Okay, so from factored form, in order to get to vertex form, we are going to have to FOIL these two binomials and turn them into a trinomial. And that trinomial is our standard form equation. So we're going to go from factored to standard before we do vertex form. Okay, so we have f of x equals x plus 3 times x plus 7. And I'm going to do we'll do the FOIL method with the letters this time, for those of you who understand it a little better that way. We have FOIL. So F stands for first. That's going to be x times x, because those are our first terms. Then we have our outside terms. That's going to be x times 7. And then our inside terms are 3 and x. And our last terms in each binomial are 3 and 7. Then we add all of those together. And then we can combine like terms to get f of x equals x squared plus 10x plus 21. All right, so we have standard form now. And remember that standard form tells us what A, B, and C are. So A is 1, B is 10, and C is 21. And in this problem, those are important because we can use them to write our equation in vertex form. So for vertex form, we first have to find our axis of symmetry. And our axis of symmetry is x equals -b over 2a. So -b would be -10, and 2 times a would be 2 times 1. And that's going to simplify to be -5. So x equals -5 is our axis of symmetry. Then to find our vertex, to find our vertex, we do f of -5. We plug our axis of symmetry in for x. And so if we have our standard form, that's going to be -5 squared plus 10 times -5 plus 21. So -5 squared is +25. 10 times -5 is -50 plus 21. We are going to get f of -5 to equal -4. So our vertex is -5, comma, -4. And we need to remember that the axis of symmetry represents opposite H, and the vertex is opposite H, comma, K. And that allows us to plug in everything into our vertex form. So it's A times X minus H squared plus K. So A comes from our original equation, and it's just a +1, so we don't have to put anything there. And then we do opposite H, so H is -5, so the opposite of that would be +5 squared, and then plus K. Well, K is -4, so that's going to be -4. Okay, so now we know all kinds of things about our equation, and we can go ahead and graph it. So the first thing I'm going to plot is my axis of symmetry, and it is at -4. Then my vertex is at -5. I said that wrong. It's at -5. -4 is the y value of the vertex. I apologize. So -5 is our vertex, or axis of symmetry. Guys, I just need to go to sleep instead of making videos. All right, the vertex is -5, -4. That's right here. Then our solutions, or our roots, or anything you want to call them, are at -7 and at -3. And that is all the information that we need to know to graph the general shape of our parabola. Okay, that is all for today. You go ahead and go and finish the entire graphic organizer, so you should have all 6 problems with all 4 blocks filled for all of them. And then take pictures and submit that. Thank you guys for listening.